Hi everyone, thank you for tuning in. My name is Adam Peck Richardson, and I'm going to be presenting the Cormorant Oceanography project. This is our 2021 update. Hopefully these will become annual updates going forward, but this is the first. Before I go any farther, I'd like to acknowledge my co-authors and really highlight the interdisciplinary nature of this team. So myself, Drs. Rachel Orban and Don Lyons, are all affiliated with the Department of Fisheries and Wildlife at Oregon State University, and specifically with the Seabird Oceanography Lab. We also work with Dr. Sabir bin Musafar. He's a professor of biology at the United Arab Emirates University in Al Ain, Abu Dhabi, and he is our expert on Socotra cormorants and the Arabian Gulf. And finally, we work with a team of oceanographers. Drs. Jim Lursak and Dylan Winters are both physical oceanographers, and Drs. Greg Wilson, Daruk Ardog, and Tuba Ozgen-Haller are all oceanographic modelers, so they develop numerical oceanographic models. So a quick outline of my talk. I'll provide some background and an overview of the Cormorant Oceanography project. I'll provide updates from 2020, including biologging tag developments and capabilities, an update on our field deployments. We'll cover data streams coming from our tags and how we're assimilating those data into oceanographic models. And finally, we'll touch on future work and potential collaborations going forward. So the objectives of the Cormorant Oceanography project are to develop biologging as a low-cost, long-term, distributed method for collecting high-quality oceanographic data. We want to continue to develop small GPS biologging tags with integrated sensors that collect oceanographic data and deploy these tags on diving marine seabirds, specifically cormorants. We continue to streamline data processing and provide public access to the data we collect. We also want to share the tools and techniques that we develop along the way. We want to facilitate international data collection through travel, partnerships, and collaborations. And we're collecting really rich seabird ecology data, so we want to make sure we're publishing that and sharing that as we go. So why do cormorants make such good oceanographers? They have a fairly broad distribution throughout our coastal oceans, from the subantarctic to the subarctic. They're relatively large, pursuit diving seabirds. They make hundreds of dives per day, so lots of opportunity to collect data. And their dives can be deep as 100 meters. But the dives are relatively short, so generally less than 5 minutes and often fairly vertical. And this means that during surface intervals, we can gather GPS locations so that we can geolocate the data that are collected during dives. And also during these surface intervals, we can collect sea surface data. And finally, their drying behavior, which you're likely familiar with, are really beneficial to solar-powered tags. So I'd like to quickly cover some of the capabilities of the tags that we are currently working with. GPS tags, so they have GPS units that provide GPS locations, and they're solar-powered, so they could last, in theory, indefinitely. The tags transfer data through wireless GSM networks, so cell phone networks, and that communication is two ways. So we receive data from the tags and updates on tag status. We can also reprogram the tags based on the workload we want to do, the types of data we want to collect, and how their batteries are performing. So the types of oceanographic data that we get from the tag includes several things. Based on GPS locations, when the birds are on the surface, we can look at surface drifts and estimate currents, current direction, and velocities. When the birds are bobbing on the surface, we can get surface gravity wave data. So this is like wave height, wave period, and wave direction. The tags are equipped with CTDs, so conductivity, temperature, and depth. And with these sensors, we can measure temperature, water temperature, and salinity during dives. And we can use these data to resolve the structure of the water column. So looking at thermoclines, haloclines, and things like that. And this plot here is actually showing real data that we collected from these tags. So you can see a series of dives, and they're colored by temperature. And you can see if you look along the yellow, you get a nice sense of the thermal structure of the water column itself. And finally, we can use pressure data to look at dive shape and dive depth. And from this, we can estimate bathymetry. So again, this is a real series of dives, and you can see how the dive bottoms are contouring the river bottom, and we can do a nice job of resolving bathymetry across an estuary. In 2020, we were really fortunate to get out to Middleton Island for a very short but productive field season. We tagged 21 pelagic cormorants that nest on the tower at Middleton Island. During our 2-week deployments, we recorded over 70,000 dives. So here we have a plot of Middleton Island. Each dot represents a dive, and they're colored by depth. And you can see we get pretty good coverage around the island. Quite an impressive amount of data. So during each dive, we're also recording other types of data. So we're recording temperature and depth. And so here we have water depth on the y-axis and time on the x-axis. And each measurement during a dive is colored by temperature. So we were able to test a faster and improved temperature sensor on the tags. And you can see it did a fairly good job of resolving the thermal structure of the water column. And finally, we deployed a novel signal booster to allow us to connect our GSM tags to the mainland cell phone network in Cordova, Alaska, over 125 kilometers away. This allowed us to connect and rebroadcast the signal around the colony so that the tags could connect and download data when birds returned to roost or attend their nests. So our second deployment in 2020 was in the United Arab Emirates in the Arabian Gulf. And here we worked with Socotra cormorants. We collaborated with Sabir bin Musafar, who is a professor in the United Arab Emirates, and he was able to tag 13 Socotra cormorants. You can see one here wearing one of our Ornitella CTD tags. We deployed tags at 2 colony locations. The first was at Butina Island in Abu Dhabi, and that is on the left here. And the second was at Sanaya Island in Al Quwain, that's on the right. And these are 2 emirates or 2 states within the nation of the UAE. So zooming in on Butina Island, we have 12 tags that were deployed there, and we've recorded over 30,000 dives in about 2 months. And so 11 of these 12 tags and 12 tags overall are still recording data. Our goal is to continue tracking these cormorants through their migratory cycle, so as they travel around the Arabian Gulf. And our oceanographic focus here is to look at surface currents and circulation. It's a really interesting inverse estuary system, so we should get some pretty interesting data out of this. So the data that we collect from cormorants is often heterogeneous across both space and time. However, these data provide direct observations, which can be quite powerful when integrated into oceanographic models that would otherwise rely solely on remote sense data. Our oceanographer colleagues work with a technique called inverse modeling. They use observations of sea surface conditions to estimate bathymetry. So here on the right, we have 3 panels showing the Columbia River estuary. The top panel is a null model, with a featureless bathymetry dropping off evenly from the shoreline. The red line here is a known transect following the north channel. In the middle panel, we have the true bathymetry. So this is the known bathymetry. And each black dot represents cormorant-derived drift speed estimates. So this is bird data. In the third panel, we have a bathymetric estimate that's derived from the null model at the top and the bird drift speed estimates in the middle panel. And here we begin to see the dredge channel entrance to the Columbia River taking shape. So now we can show that cormorant-derived oceanographic data can improve model skill. So in this plot, on the bottom left, on the y-axis we have depth, and the x-axis we have distance along the transect line. The red line here is the same transect that we see in the maps on the right, and the black line is the true bathymetry as you pass along this transect. The blue line here is the estimated bathymetry based solely on the sparse cormorant data. So even with this limited data set, we begin to resolve bathymetry pretty neatly, and we can also start to incorporate other types of data. Cormorant depth soundings, and wave height estimates can also be incorporated in this type of model. So as we look to the future, we're going to continue to develop biologging tags through our collaborations with manufacturers. And this includes testing prototype tags. So this tag on the left here is a novel CTD biologging tag, so a salinity biologging tag. And the donut on the back of the tag is an inductive conductivity cell. So this is a contactless conductivity cell that can provide stable measurements of salinity. This would be a really big breakthrough. We're kind of at the early stages, but we're hoping to have a tag like this in hand just in the next few weeks. We'll also continue to streamline data analysis and our publishing. And so that includes near real-time acquisition of data and processing of that data. So these are big data sets, and there's a lot to deal with to get the oceanographic data that we want from these raw data sets. And we're going to continue to work to distribute data publicly. And right now we're doing that through a collaboration with the Animal Telemetry Network. And we also want to continue to develop new partnerships and collaborations. So to build off of that last point, we are really interested in collaborating. So if you work with cormorants, if you have ideas for interesting biologging projects, if you have questions about what we do, if you're just curious about biologging and oceanography, please reach out. I'd love to talk to you. I think it's fun to talk about cormorants. I think it's fun to talk about biologging. So please get in touch, and I hope to hear from some of you. And with that, I'd like to acknowledge our support. Our funding comes from the Office of Naval Research. A special thanks to Reggie Beach. Our work at Middleton Island was made possible by Scott Hatch and Jenna Schlenner, and the Institute for Seabird Research and Conservation. Thank you for making it possible to do work on Middleton during a COVID year. And also thank you to Jillian Solar and Brendan Higgins, our 2020 field crew at Middleton Island. They were great. And with that, I'm happy to answer any questions in the remaining time that we have. Thank you so much.